Assalamualaikum warahmatullahi wabarakatuh. This is Muhammad Abdullah. Welcome back to the channel. I'm Vishisay. And in today's class, we are going to learn about the concept Ohm's law. Ohm's law is very important fundamentals of the chapter electricity. This is not only important for the class 10, but also important for diploma and engineering. Alright, without wasting much of our time, let's get started. We are going to learn about the concept of Ohm's law, and Ohm's law statement says that if you keep the physical conditions of the wire, just like length of the wire, area of cross section, temperature of the wire are kept constant, then the current passing through the conductor is directly proportional to the potential difference applied across the ends of that conductor. It says that whatever the amount of current passing, that current passing is directly proportional to the voltage applied. That means if you increase the amount of voltage, the current passing will also increase. And if you decrease the amount of voltage applied across the conductor, the current passing will also decrease. Right? So let's not waste the time. Let's get into the lab activity and we can better understand how Ohm's law works. And then we have these cute characters to look at to understand the resistance and the current and the voltage. Alright, so let's just switch to the lab activity now. Okay, here we are for the lab activity. For lab activity, we need some essential materials, like we need a resistive element or the load. We need a resistor or resistive load, right? So we have resistor here, and what we need is we need wires. We need conducting wires. We need conducting wires for connecting the circuit. And just a second, let me change the color. We need conducting wires. We need battery that is going to act as a source to our circuit, and we need a voltmeter to measure the voltage. We need the ammeter to measure the current, right? Remember, these instruments we are using are of DC supply because the battery provides you DC source, right? DC electrical energy. Okay, let's just go get into the circuit and let's make the circuit now. As I said, we need a battery. Just a second. As I said, we need a battery, and I took a battery. We need a switch to control this circuit, and we need a resistor, or you can use the bulb as well. All right, okay, and we need wires, conducting wires. Okay, I have connected this conducting wire here, and let me connect it here. And I also need the ammeter, so I'm taking this ammeter here. Let me connect this ammeter like this. Just a second. Okay, we need a wire here as well, which connects to this ammeter, and we need to connect this wire to our ammeter. Here we are. And let's have a look at the voltmeter. We also need the voltmeter to connect. But before that, let me complete the circuit. Any electrical circuit is said to be incomplete until you close the circuit, right? So we have a switch to open and close the circuit, and we also need a voltmeter to measure the voltage, right? Okay, let me place the voltmeter over the top, and we have two probes. These are called as the probes of the voltmeter. And let me place the probes across the ends of the resistor. I need to connect it across these two ends. Right, now the switch is open, that's why there is no current passing. Let me select the battery. Battery is of 9 volts. Consider I am taking the battery to be of 5 volts. Okay, we will increase the voltage of the battery in terms of 5. Okay, let's just start. So I'm turning on the circuit. I switched it on. Now you can see the electrons have started to pass. The current is started to flow. And what is the voltage here? The voltage given is, voltage measured is 5 volts. That is, let me draw the chart here, VI chart. The voltage given by us was 5 volts, and the amount of current passing, if you see here, what is the amount of current passing? That is 0.5 amps of current passing. Okay, now let's change the values of the circuit. As you just learned that Ohm's law says that if you increase the voltage, the current passing in the circuit must increase. So we need to increase the voltage. Let's increase the voltage then. I'm clicking on the battery. Let me first break the circuit, click on the battery and increase the voltage to 5 from 5.0 to 10 volts. So here we have 10 volts of supply. Okay, let me make the circuit again. You can see that if you turn on, you will find that the current is still passing and the amount of current passing now has changed, right? So let me note down that reading. For 10 volts, I have the current passing is 1 ampere. Okay, very good. Now let me increase furthermore to have a clear understanding. I'm increasing it to 15. Let me just do it quick. I have, okay, voltage 15 volts. Alright, good. And now you can see the amount of current passing has also changed from 1 amps to, you can see it's 1.5 amps now, right? Great. So let's now try to understand what Ohm's law is trying to say. Ohm's law is trying to say that if you increase the voltage, the current will increase. But not only increasing, it will increase in proportion. It will increase in proportion. Okay, what do you mean by the proportion? It will increase in a fixed ratio. Let me try to prove you, right? If you do V by I, let's do the ratio V by I. So 5 by, first value will be what? 5 by 0.5, which is nothing but, if you remove the decimal over the top, the 0 will come up and 5 ones are 5 tens are, the answer will be 10, right? And do it here for this value too. We have 10 and 1, 10 by 1, you will get 10 again. You have 15 by 1.5 and you have the value again as 10. What have you understood with this concept? You understood that the amount of current passing will increase if the amount of voltage given is also increasing, and the voltage applied is decreased, then the current passing will also decrease. And if you see that they will increase and they will change in such a way that their ratio will always remains to be constant. What this constant is, Ohm's law, Ohm's have concluded that this value is nothing but the resistance of the material. Ohm says that this value is getting constant, and this is constant because of the material, and hence this is the property of the material. This is the property of the material, and this property is called as resistance, right? What is the resistance of this resistor now? Currently, this resistance of the material or this resistor is 10 ohms. Let me have a look at the value now. To ensure and to double check it, let me verify and let me check the value. First, let me disconnect the circuit. Let me remove the probes and let me click on the resistor, and you can see the value of the resistor is 10 ohms, right? So I hope you understood the concept. The concept says that if you increase the voltage, current passing must also increase in such a way that the ratio of V by I must be remaining constant, and this will be only constant when the physical conditions like the length of the wire is remaining constant, the area remaining constant, and the temperature remaining constant. Okay, so you have learned it better. Let's now have a look at the graph. If you plot the graph for these values like V5, 10 and 15, you would be going to get a straight line. Let me switch to the graph now. Let me have a look at the graph. So for that, I'm taking the graph paper, and let me have a new page. Okay. What were the values we had just now? We had the values like 5, 10 and 15. Let me plot the graph now. I'm plotting the graph here. This graph is called as VI characteristics. VI characteristics in the sense, this graph has voltage on one of the axis and current on the other axis. The current measure here was in ampere. You can take anywhere. The current can be taken at x-axis as well as at the y-axis. There is no problem. And if you take voltage at y-axis, no problem. You can also take it at the x-axis too. All right. let me just divide this unit. We had every single unit, we had changed the values in 5, right? So let me take each 2 units of the graph as 5 volts. So another 2 unit will become 10 and another will become 15. All right, no problem. Okay, and next let me have a look at the current, and let me take the 2 units of current as 0.5 amps. Each unit is nothing but 0.25. 2 units is nothing but 0.5, and here 1 amp, and for these two I am going to plot 1.5 amps. Let me draw the graph. What have you understood with the values just now? You have seen that if the voltage was 5, the current passing was 0.5. The current passing was 0.5. That means for these 5 volts, the current passing was 0.5, and the value comes here, the point comes here. And for 10 volts, the current passing was 1 amps, and so the value is here. The coordinate is here. Okay. And for 15 volts, the current passing was 1.5 amps, and the point comes here. And if you see, this is nothing but a straight line, right? We have just learned now that Ohm's law is verified only if the graph appeared to be a straight line, a linear line. All right. Okay. So this was all the concept of Ohm's law. Ohm's law we have learned better in the sense like if the voltage is increased, current will also increase, right? The voltage is decreased, current will also decrease. We have learned that V and I are proportional to each other, directly proportional. If you want to remove the proportionality, if you want to equate and get the equation, you need to add proportionality constant. And if you see in the Ohm's law sense, the Ohm's law says that if you divide V by I, you would get a constant value, right? This constant, he explained that V by I is nothing but the resistance of the material, which he denotes by the letter R, right? That means we got a relation that V by I is equals to R. If you send this I that side, this is nothing but V is equals to I into R. This is the very fundamental formula called Ohm's law. Ohm's law is equals to V by R, where V is the voltage applied across the wire, I is the current passing through the wire, and R is the resistance of that wire. V is the voltage applied, I is the current passing through the wire, and R is the resistance applied across resistance of that wire. Okay. So this was the concept about Ohm's law. I hope you understood the concept very well and you have learned Ohm's law very well, right? Ohm's law, the cute characters of the cute characters here represents the resistance. This cute character, which is having the symbol called ohm, this measures the resistance. Resistance is measured in terms of ohm. If you see here, this character is trying to suppress the path. It is obstructing the path. It is blocking the path. So the resistance of the material, obstruct the flow of electrons. Obstructs the flow of electron. That is, it opposes, in simple sense, if you want to understand it much better, it opposes the flow of electron. It opposes the flow of electron. This property of opposing or obstructing the electron is called as resistance, resistance of the wire. Every material will have certain or the other resistance, and this resistance, if the resistance is high, the current passing will be less. If the resistance is less, the current passing will be high. This cute character A is the current, and this cute character V is the voltage. Voltage always pushes the current. The current passing is due to the voltage. Greater the voltage, greater the pushing force, greater is the amount of current passing through any wire. And if lesser the pushing force, the current passing will be less. And if the resistance is high, the obstruction is high, the current passing will be less. So this is what the Ohm's law says. I hope you understood about the Ohm's law very well. Do consider to share and subscribe this video.
थैंक यू सो मच गाइस। उम्मीद करता हूं ये वीडियो आपको बहुत पसंद आया होगा। ऐसे इंटरेस्टिंग वीडियोस के लिए साइंस लेक्चर्स 9th to 12th और सीबीएसई स्टेट के लेक्चर्स, इंटरेस्टिंग प्रोजेक्ट्स, आरसी प्लेन के लिए मेरे चैनल को सब्सक्राइब जरूर करिएगा। लाइक करना तो बनता है, बेल आइकन दबाए बिना जाना नहीं। That's it for today's class. Stay tuned to my channel, Ambitious AB.